Hello viewers, this is Wagadara now taking you through the story of A-level subsidiary mathematics. And this video we're going to go through the topic of normal distribution. So this topic is under probability and is suitable for students in both senior 5 and senior 6 offering subsidiary mathematics. So if a continuous random variable x is normally distributed with mean mu and variance sigma squared, we write this as that. So this represents that x is a random variable following a normal distribution with mean, mu and standard deviation that. So always you must get used with this symbol because we shall use it more frequently. So whatever they put here first will be the mean, and what they put here will be the variance, as long as here there is capital N. The most important normal distribution is the standard normal distribution, and is given by the symbol Z, which has a mean of 0 and a variance of 1. Therefore we write this as, this means that random variable Z follows a normal distribution with mean 0 and variance 1. So like I said, what they put here will be the mean and what they put here will be the variance, as long as this is capital N. Now we also have to know how to sketch a standard normal curve. So a standard normal curve is of this shape, which is a bell shape. We call it a bell shape. So it will always be of that shape, and here it is symmetrical, and at the center this is 0, mean 0, and the values from 0 going to the right are positive, values from 0 going to the left are negative. So these are Z values. So this is an Z axis, and this is an axis of FZ. And I think we realize that the area which is shaded denotes phi ZP. So this phi ZP is the same as probability. As you can see here, the note says the areas under the curve show probabilities, and that is therefore the shaded area here shows the probability that Z takes on values from 0 to ZP. So I think we see that we shaded from 0 up to ZP. Therefore, when they want the probability that of Z taking on values from 0 up to ZP, in other words, probability of Z greater than 0 but less than ZP, that would be this area, and it's denoted by the symbol phi. So this symbol phi, we shall use it more frequently. It implies that the probability starts from 0 up to this value in the bracket. So if, for example, this ZP is 3, it implies that they want the probability from 0 to 3. If Z is 2.5, it means they want the probability from 0 to 2.5. So that is what this symbol phi means. So you have to be keen of it because we shall use it more frequently. Now we shall start with part A, which is shading required probabilities. So what you should know is that the areas under the curve shows probability, and the curve is symmetrical about mean 0. I think you saw that. According to the shape was in this form, meaning that it is symmetrical. Then another point to note is that the total area under the curve is 1. So this is very vital, because by symmetry it implies that it divides this curve into 2, meaning that this part will have a probability of 0.5 and this one also have a probability of 0.5, but we shall see that in details when we go to the next part, where you have to get individual probabilities. So by symmetry, this area is divided into 2 equal parts. So that is what we need to know at this point. So we shall start with the question, and the question says that represent the following probabilities on a sketched, note that we are using a sketch, not an actual diagram. So on a sketched standard normal curve. Now standard means that at the symmetry there is a value of 0, which is the mean. Standard normal curve by shading the wanted region. Note that we are shading the wanted region. So these are the probabilities: probability of z less than 0.123, probability of z less than negative 1.189, probability of z greater than 1.561, probability of z greater than negative 2.857, probability of z greater than 1.45 but less than 2.990, and probability of z greater than negative 1.002 but less than 0.179. And lastly, probability of z greater than negative 2.999 but less than negative 0.199. So those are the probabilities those are the sketches we shall draw. So let's see how they are drawn. So like I said, we shall start with part A, probability of z less than 0.123. And like I say, the shape of the standard normal curve is the same, so it will always be of that shape with 0 at the center. Then after that, you look at this value. This value is positive. Like we said, if this is 0, positive values are this side and negative values are this side. Now because this is positive, we are going to put it anywhere in this side which denotes positive values of z. So you come and put it somewhere, let it be there. Then next we shall look at the inequality, probability of z less than this. So the values here less than that are from there going this side, because this side means they are greater than, but this sign shows less than, meaning that we are going to shade from here going to the left. So let's do that. So that is the shading they wanted in this part. So like we said, phi denotes probability from 0 to a z value. So from here up to here, it will be a probability of z greater than 0 but less than 0.123, and it will be denoted by phi 0.123. Now this other probability, I think realize that the whole of this half here has been shaded. Therefore, like we say that this shape is symmetrical, it implies that the whole of this probability is 0.5. So we shall come and put there 0.5. So that is a sketch of part A. Now we shall go to part B, where they want probability of z less than negative 1.189. So it's somewhat similar to part A, but this time there is a negative there. So what we shall know that always the sketch of the standard normal curve is the same, so it will be that with 0 at the center. Then we shall look at this value. This value is negative, meaning that it will be somewhere in this region. So let's put it there. After that, we shall look at this inequality, z less than negative that, meaning that negative is always to the left. So when they say greater than, it will be to the right. By this time they say negative, so we shall shade going to the left. So from, like I said, from the probability from 0 to a certain value is denoted by phi. So this phi negative 1.189 means denotes the probability of z taking on values between this and that. So what does that mean? It means that this one, which is remain left, is equal to 0.5 minus this probability. Remember, the whole of this half from here up to the end has a probability of 0.5. Therefore, if from here up to here is phi negative 1.189, it implies that the remaining part will be got by saying 0.5 minus phi negative 1.189. So these sketches are very vital because they are going to help us in the next step of this topic. So now we shall go to probability of z greater than 1.156. So somewhat similar, but this time instead of saying less than, they have used the word greater than. So we shall first sketch a standard normal curve, which is always the same, with mean 0 at the center. Then we remember that this value is positive, so we shall put it anywhere in this side part. So let's say it be there. Then next we shall look at this inequality greater than. Like I said, greater than means that we're shading going to the right. So we are going to shade going to the right, and that will be the shading. Then after that we shall remember that the probability from 0 to a z value is noted by phi. So the whole of this from here to here is phi, but the total is 0.5, meaning that this part remaining, which is actually shaded, will have 0.5 minus phi of 1.561. So these sketches we are drawing are very vital for the next step. So you should make sure that you understand every step that we take. So now we shall go to part D, where they want probability of z greater than negative 2.857. So somewhat similar to this, but this was positive and this is negative. So we shall first draw a standard normal curve with mean 0 at the center. Then we shall look at this value. This value is negative, meaning that we shall put it anywhere this side of 0. So let it be at that point. So after that we shall look at this inequality greater than. We said greater than means that you shade going to the right, just as the arrow points. So we are going to shade the whole of that. Then you should remember that probability from 0 to a z value is denoted by phi. So the whole of this probability is phi of negative 2.857. And I think you see that this other half, the whole of it is shaded, meaning that the total probability will be 0.5. So now we shall go to part E. So part E, the one the probability of z greater than 1.542 but less than 2.990. So now that they want the to shade from the values of z range from the 1.542 up to 2.990. So the sketch first of all is a standard normal curve, which is always the same with mean at the center. Then after that we shall look at these values. Both of them are positive, meaning they will both be this side. But if you look at them, this one is smaller than this, meaning that 1.542 will be closer to 0. So let's put it there. And then this will be further from 0, so we shall put it there. Now the shading they want is from this up to this, so we are going to shade the whole of this area. Okay, so now like we said that phi denotes probability from 0, so phi of 2.990 is the whole of this from here up to here, and phi of 1.542 is from here up to here. Now if I want to get this balance, it means that I have to subtract the phi of 1.542 from phi of 2.990. That is why here you see that the shaded area is equal to phi of 2.990 minus phi of 1.542. So all these steps we are taking are very vital, so you ought to be following. So now we shall go to part F, where they want the probability of z greater than negative 1.002 but less than 0.179. First, sketch the standard normal curve, which is always the same with mean at the center. Then when you look at these values, this one is negative and this is positive. Now the negative value will lie this side, so let's put it somewhere there, and then the positive value will lie this side, so let's put it somewhere there. Now the values they want is from here up to here, meaning that we are going to shade from this going this side up to there. So let's do the shading. Okay, so now after that we remember that phi means values from 0 to a z value. So this phi of negative 1.002 denotes probability from 0 up to negative 1.002, and this phi of 0.179 denotes probability from 0 up to 0.179. So when we add all these two, we shall be able to get this probability which they want. And lastly, part G wants probability from Z of Z greater than negative 2.999 and less than negative 0.199. So first of all, we shall sketch the standard normal curve with mean at the center. Then we shall remember that both these values are negative, but the question is which one is closer to 0. You realize that it is negative 0.199 which is closer to 0, so we shall put it there closer to 0, followed by this which is further away from 0, so we shall put it somewhere there. Now the values from here up to here will mean that we are going to shade from here up to there. So let's do the shading, and that one will be denoted by phi of negative 2.999 minus phi of negative 0.199. Remember we said phi denotes probability from 0 up this value, so phi of negative 2.999 is denotes probability from here up to here, and phi of negative 0.199 denotes probability from here up to here, meaning that the balance will be got by subtracting the two. So now we have learned how to shade. Now let's go to the next part of of getting individual probabilities. So this is the area under the probability is the area under the normal distribution curve, and is got from mathematical tables or of cumulative normal distribution. So now I believe you have your mathematical logbooks with you, because we are going to use them very frequently in this topic. So, and the table we are going to use is the one for cumulative normal distribution. So you should be keen, because there are two tables. One has only the word normal distribution, but the one of interest is one which also has the word cumulative. So we are going to use the table of cumulative normal distribution in this video. So for you to get the probabilities, like we saw in the previous part where we are shading on the standard normal curve, the standard normal curve has a random variable z, but usually the probabilities which will be given will have a random variable x. Just as we see these probabilities, they all have random variable x. So when it is still x, you cannot use the standard normal curve, so you have to first convert it to z using this formula that z is equal to x minus mean over standard deviation. After converting to z, then you can show the probability on a standard normal curve, and then after which you can use the cumulative normal distribution. So what you should remember is that always the random variable x must be converted to random variable z in order to show it on the standard normal curve, and after which you can use the cumulative normal distribution to get the required probability. And what you should remember is that this z value got after using this formula must be to 3 decimal places. So the z value is 3 decimal places, and the probability at the end is 4 decimal places. You should not confuse the two. So with that, now let's go to question 2. So question 2 says, find the following probabilities. So part A, the probability of x less than 50 if x follows a normal distribution with mean 40 and variance 25. And part B, probability of x greater than 28 if x follows a normal distribution of mean 24 and variance 6. And lastly, probability of x greater than 52 but less than 63 if x follows a normal distribution with mean 50 and variance 5 squared. So we shall start with part A. So part A, they want the probability of x less than 50 if this x is a random variable which is normally distributed with mean 40 and variance 25. So the first thing to do is to standardize, in other words, to convert from capital X to capital Z. I think we see that in this part, which if you look at these two parts, this is capital X, this is capital Z. That means that this value has to be converted to a Z value using the formula which you have seen in the previous slide of x minus mean over standard deviation. So in this case, the x value is this 50, which is given in the question, and the mean is here. Remember we said if this is capital N, it means that this first value is mean and this one is variance. So the mean is here and this is variance, but a good thing we know that standard deviation is the square root of variance. So to get standard deviation, you shall get the square root of that value and put it there. The next is to use a calculator. So when I use a calculator to simplify this part, I'll come up with 2.000. So what you should realize is that the inequality sign is maintained. Here it was the less than, even here too should be less than, and at the end it should also remain less than. So the inequality sign is maintained. It is only the random variable which changes. It was capital X here, and after standardizing it becomes capital Z. So now that we have standardized, also we have changed from capital X to capital Z, we can now show this probability on a standard normal curve. So we shall first draw a standard normal curve with mean at 0 at the center. Then we shall look at this value. Now this value is a positive value, meaning that it will lie somewhere in this part. So let us put it there. After that, we shall look at the inequality. Inequality says z less than 2.000. It means that from this value less than, you shade going to the left. So we are going to shade all that part. So let's do that. Okay, then after that we remember that phi means probability from 0 to that value. So phi of 2.000 is the probability from 0 up to that value, which is 2.000. And this other part, I think we realize that the whole of this half has been shaded, meaning that the probability there is 0.5. Now this probability which they want here is the probability of the whole of everything that has been shaded, in other words, from here up to here. And for you to get that probability of whatever has been shaded, it means we're going to add this to this. So let's write that. As you can see here, that this probability is equal to 0.5 plus phi of 2.000. We have to add this and this to get what has been shaded. Now after that, you ask yourself, how can I get this probability of phi 2.000? So that is where the mathematical table comes in. So get your mathematical tables and open the part which has cumulative normal distribution. Like I said, there are two mathematical tables. One mathematical table, one has only normal distribution, but the one we are interested in is the one which also has the word cumulative normal distribution. So when you get that table, this is how it looks like. It has here z, then here it has values from 1 to 9, from 0 to 9, but here it is from 1 to 9, and it has here add, then here there are values of z. Now this column here shows values of z with 1 decimal, and this one shows the second decimal point of z, and this one shows the third decimal point of z. That is why I told you that when you are calculating or standardizing, the z value must be to 3 decimal places. Always remember that. So those are the z values. Now these values in the body, all these values in the body are the probabilities, we shall see how we can use them to get the probability of interest. So in this case, in this question, they want to get phi of 2.000. So it is 2.0. So what you're going to do, like I said, the first decimal point is got in this part. So in this part, you will look for 2.0, which is here. Then the second decimal point is got in this part, and since it was 2.00, the second decimal point is 0, which is there. Now the third decimal point is got in this part, and the third decimal point was 0, but since this one starts from 1, it implies that 0 is ignored. Therefore, we shall take only this and that. Now the intersection, if you stand here and go horizontally, and stand here and go vertically downwards, the probability you reach on is this one, which is 0.4772. Now that is the probability of interest, and that is what we are going to put under phi. So what I didn't tell you is that this table shows probabilities with phi. So the probability of phi, so this phi 2.000 will be 0.4772. But remember, there was also this 0.5, so when I add the 2, I'll come up with 0.9772. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this one has to be to 3 decimal places. Then M1 for addition, for you to know that you are going to add this probability to this probability. Then B1 for table value, for you to be able to use the table value, the table correctly, and read off this probability correctly. That is also B1, and A1 for the output after adding. So that has been part A. Now we shall go to part B, where they want the probability of x greater than 28 if x is and follows a normal distribution with mean 24 and variance 6. So still we shall do the same. We have to first standardize to change from capital X to capital Z. So when I change, the formula is still the same, x minus mu over standard deviation. So x is this value, which is there, then the mean is this value, which is there, and standard deviation is square root of variance, which was there. So when I use the calculator to simplify this, I'll come up with 1.633, and we should remember that the final answer here must be to 3 decimal places. Then also the inequality sign does not change, it must be maintained. For example, here it was greater than, even here it is greater than, and even here it is greater than. So after that, we shall now draw our sketch of the standard normal curve. So it is always the same with mean at the center of which is 0. Then next is to look at this value. This value is positive, meaning that it will lie in this part of the curve. So let it be there. After that, we look at the inequality. This one means greater than. Greater than means you shade going to the right. So let's shade that. Okay. Then after that, you shall remember that phi denotes probability from 0 to that z value. So from here to here is phi of 1.633. What does that mean? It means that this shaded part will be 0.5 minus phi of 1.633. So I think you know why we are saying this, because the total of this and this must be equal to 0.5, because from here up to here is 0.5, and from here up to here is phi of 1.633, meaning that this remaining part will be got by subtraction. So this probability is this shaded area, therefore we shall come and write that probability is equal to 0.5 minus phi of 1.633. Then we shall use a mathematical table to get this value of 0.4487. So let's see how it is got. So first of all, like we said, the first decimal point comes in this column, so 1.6 is there, The next decimal point is 3 because it was 1.633, so the second decimal point is 3. So we shall come at this column and look for 3. So take it down and look for this intersection of this and this, which is that. Then the third decimal point was also 3, so come in this part of third decimal point and look for 3, then take it down to meet this very horizontal line. So the easiest way to do it, you put here a ruler where you see this dotted line. For you on your mathematical table, you put there a ruler so that you get a correct value. So what are getting those values? We have got 4484 and 3. So how do they use them? What you should remember is that probability must be to 4 decimal places. So if you look at these first values, they were helping you by putting there 0.0.0, but these other values, because of space, they couldn't put them there. So what you should remember is that the probability must be to 4 decimal places. So if you look at this, these are 4 digits, meaning that to make 4 decimal places, it will be 0.4484. So this one corresponds to this. But for this one, to make it 4 decimal places, it will be, you add the 3 zeros in front of it, so it will be 0.0003. So these are 4 decimal places, 1, 2, 3, 4. So always remember that the probability must be to 4 decimal places. So the values got here, you have to change to make them to 4 decimal places. So when we add this and this, we shall come up with 0.4487. So that will be the value of phi 1.633. Therefore, that we shall come here and substitute for phi 1.633 to become 0.4487. And when I subtract these two, I'll come up with 0.0513 as my answer. So let's see how marks can be awarded. So M1 for standardizing, this M1 for this subtraction, and B1 for reading the table value correctly, and A1 for output. So that has been part B. Now we shall go to part C, which says that find the probability of x greater than 52 but less than 63 if x follows a normal distribution with mean 50 and variance 5 squared. So the first step is to standardize. Like I said, you maintain the inequalities, but you keep on changing. So this was capital X, it becomes capital Z. And when it becomes capital Z, it means that this value has to be standardized by using the formula that x minus mean over standard deviation. So this one is our value of x, then the mean is here, and standard deviation is the square root of variance. So square root of this gives you 5, which is there. You do the same for this 63. So 63, that is the value of x minus mean over standard deviation, which is the square root of variance. The inequality signs must be maintained. You see this one, it is the same as this, and this is the same as that. So next is use the calculator to simplify to 3 decimal places. So the whole of this to 3 decimal places is 0.400, and this one to 3 decimal places is 2.600. After that, now we have to sketch the probability. So first of all, you have to know that the sketch is standard with mean at the center 0. Then after that, we realize that both values are positive, meaning they will both be this side. But the first one must be the one closer to 0. So 0.4 is 00 is closer to 0, so we shall first put it there, closer to 0, followed by this, which is further away from 0, so we shall put it there. Then now this probability is the area from this up to this, so I have to shade from 0.4 up to 2.6. When we shade, we shall come up with that. Then after that, we shall remember that phi means probability from 0 up to that z value. So to get this shaded part, it will be phi 2.600, which is from 0 up to 2.600, minus phi 0.400, which is from 0 up to 0.400. So this remaining part will be got by subtraction. That's why you see here they are being subtracted. After that, you shall remember that this probability is equal to this shaded area, so you shall come and write down that is equal to phi of 2.600 minus phi of 0.400. After that, we shall use our mathematical tables. So if you look at this mathematical table, we want to first look for 2.600, so 2.6 is here and 0 is here, so it corresponds to that. But this third decimal point, like because it starts with 1, it implies that the third decimal point of 0 is ignored, so we shall take 2.60, which is 0.4953. Then the other one was 0.400, so 0.4 is here, and the second decimal point is 0, which is there. The third decimal point is 0, but 0 is not here, so it can be ignored, so we shall get our probability as 0.1554. So those are the values we are going to write. So when we come here, we shall write this as that and this as that, and when we subtract, we shall come up with 0.3399. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, and the values must be to 3 decimal places. M1 for this subtraction, B1 for this first table value, and this one for the second table value correctly read, and A1 for the output after subtraction. So that has been individual probabilities. Now we shall go to part C, which talks about symmetrical probabilities. So this one is not far different from the previous one, but the only difference is that by symmetry, the probability of z of phi, the probability of when z is negative zp, and this probability when z is positive, they are the same by symmetry. So phi of negative zp and phi of zp are the same. In other words, the probability of z taking on values between negative zp and 0, and the probability of z taking on values between 0 and positive zp will be the same, because they both cover the same area. So always remember this. So in this part of symmetrical probabilities, this is the only element we are going to add in. Now the reason why we do this is because in your mathematical tables, I think you realize that there are no negative values of z. Therefore you have to remember that by symmetry, the negative values of z will be the same as the positive values of z. Then you can proceed with your working. So since that, I hope it has been understood. Now we shall go to question 3. Question 3 says, find the following probabilities. 1 is probability of x greater than 107 if x follows a normal distribution with mean of 120 and variance of 40. And part B, x less than 15 if x follows a normal distribution of mean 17 and variance 3 squared. And part C, probability of x greater than 0.45 but less than 0.55 if x follows a normal distribution with mean of 0.6 and variance of 0.04. And lastly, probability of x greater than 240 but less than 280 if x follows a normal distribution with mean 260 and variance 15 squared. So now we shall start with part A. So part A says they want the probability of x greater than 107 if x follows a normal distribution of mean 120 and variance 40. So the first step is always to standardize. So we shall standardize this. Capital X becomes capital Z, and this inequality sign is maintained, but this one x value changes to a z value, which is x minus mean over standard deviation, which is the square root of variance. So when I simplify this using a calculator and I round off to 3 decimal places, I'll come up with negative 2.055. After that, next is to sketch. So I'll first draw a standard normal curve with mean at the center 0. Then I realize that this value is negative, meaning that it's on this side of 0. So I'll put it somewhere there. Then I'll look at this inequality. Greater than means shading goes to the right. So I'll shade going that side. So let's do that. Okay, now that I remember that phi means probability from 0 to a z value. So from here up to here, the probability is phi of negative 2.055, and the whole of this area is shaded, meaning the probability will be 0.5. Now this given probability is the whole shaded part, so it will be this plus this to give me that. So I'll come here and say that the required probability is 0.5 plus phi of negative 2.055. But remember, like I said, by symmetry, our mathematical tables don't have negative values of z, so we shall remember that by symmetry, phi of negative z value is equal to phi of a positive z value. So in this step, we shall come and say that is the same as, this one is the same as phi of positive 2.055. Now that I've got that, next is to use a mathematical table to come up with the value of phi 2.055. So 2.0 is there, then second decimal point is 5, they intersect at that point, then third decimal point is also 5, it intersects at that point. So after that, you remember that the probabilities must be to 4 decimal places. So these are 4 digits. To make to 4 decimal places, I'll only add 0 point. But this one is 1 digit, so I'll have to first add 3 zeros and then I add a 0 point, so it will become 0.0002 to make them 4 decimal places. After that, I'll use a calculator to add these two to come up with 0.4800. So that is the probability of phi 2.055, and that's what I'll come and write here. So this is that. Then when I use a calculator to add these two, I'll come up with 0.9800. So basically that's what they wanted. Let's see how much can be awarded. M1 for standardizing and should be to 3 decimal places, M1 for this addition, and B1 for reading the table value correctly, A1 for the output after adding. So now we shall go to part B. So part B says find the probability of x less than 15 if x follows a normal distribution with mean 17 and variance 3 squared. So the first step is always standardizing. So this is capital X, this becomes capital Z. The inequality sign is maintained. Now this X value is what should be converted to a Z value. So 15 is there, minus mean there, over variance, which is square root of standard deviation. So when I use the calculator to simplify this and round off to 3 decimal places, I'll come up with negative 0.667. After that, I have to sketch. So in sketching, I remember that this one is a negative value, meaning that it lies on this side of 0. So let me put it somewhere there. After that, I look at the inequality. Less than means your shade going to the left, so I'm going to shade that part. Then from there, I remember that phi means probability from 0 to a z value. So from 0 to this value is equal to phi of negative 0.667. But since the whole of this is 0.5, it means that the remaining part is 0.5 minus phi of negative 0.667. Therefore, this probability is equal to the shaded part, which is 0.5 minus phi of negative 0.667. Then from here, we shall remember that by symmetry, phi of a negative z value is equal to phi of a positive z value. After that, I have to look for this value in mathematical table. So 0.667. So 0.6, the first decimal point is 6, second one is 6, so it goes there, and third one is 7, so it goes there. After that, I remember that the probability must be to 4 decimal places, so these are 4 digits. I'll have to just add 0 point, but these are 2 digits, so I'll have to first add 2 digits, 2 more zeros before I add a 0 point. So that's why here it is 0.2454 and here it is 0.0023. The next is use the calculator to come up with 0.2477. So that will be the value. I'll come and write under that, and when I use the calculator, I'll subtract and come up with the probability as 0.2523. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, and this should be to 3 decimal places. M1 for this subtraction, B1 for reading the correct Z value, and A1 for the output after subtraction. So now we shall go to part C. Part C is find the probability of x greater than 0.45 but less than 0.55 if x follows the normal distribution with mean of 0.6 and variance of 0.04. So the first thing is to standardize. The inequality signs must remain the same. So this x becomes z, but the inequality signs are maintained. I think you see this is maintained and this one is also maintained. But this x value has to be converted to a z value by using the formula that x minus mean over standard deviation. So this is an x value and this is the mean, and this standard deviation is the square root of variance. Similarly, this one must also be converted, so that is the x value, mean is that, and standard deviation is square root of variance. After that, we shall use our calculator, and if I use a calculator to simplify this and round off to 3 decimal places, I'll come up with negative 0.750, and this one rounding off to 3 decimal places, I'll come up with negative 0.250. Now next is to sketch a standard normal curve. So remember that this one is both a negative. This is negative and this is negative, meaning that both will lie this side of 0, but negative 0.250 is closer to 0 than negative 0.750. So we shall put negative 0.250 closer to 0 and this one further away from 0. After that, this area from between this value and this value will be the whole of this shading from here up to here, so we shall shade that. Other we shall remember that shaded part will be equal to phi of negative 0.750 minus phi of negative 0.250. Why? Because phi of negative 0.750 is the probability from here up to here, and phi of negative 0.250 is from here up to here, meaning that the remaining part will be got by subtraction. Therefore, this probability is equal to this shaded area, so we shall come and write it down here. And now next is to use the mathematical table to come up with this value and this value. So 0.75, 0.7 is here. The other value is this. So I think you realize that when you move this side, when you reach here, this is an empty space, meaning that you have to move down because these values are still values of 0.7. Therefore, when you drop down, it will land on this one, which is 2734. The third decimal point was 0, so it is ignored because here there is no 0. The next is the probability of 0.250. So 0.2 is there, then you also look for 5 here, drop it down to meet this line, and the value is 0987. Now most students forget this 0, but this 0 is there, so you shouldn't ignore it. Therefore, this probability here, it will be, like I said, there should be 4 decimal places. So this one will be 0.2734, and this one will be 0.0987. So you come and substitute. So by symmetry, this is that, this is that. So when you substitute, you come up with this for this and this for that. Then you subtract to come up with the final answer as 0.1747. So basically that's what they wanted. Now let's see how marks can be awarded. M1 for standardizing, they should be to 3 decimal places. M1 for this subtraction, B1 for this first Z value, another B1 for this second Z value, A1 for the output after subtraction. So now we shall go to part D, where they want the probability of x greater than 240 but less than 280. If x follows a normal distribution with mean 260 and variance 15 squared. So the first thing to do is to standardize. So standardizing, this capital X becomes capital Z. The inequality sign is maintained here and here. But the value, this is our next value, it has to be converted to a Z value using the formula that x minus mean over standard deviation. So this is the value of x, the mean is 260 and standard deviation is square root of variance. Similarly, this one has to be converted, so x is there, then the mean is 260 and standard deviation is square root of variance. Now next is to use a calculator and round off to 3 decimal places. So when I simplify this using a calculator and round off to 3 decimal places, I'll come up with negative 1.333, and this one round off to 3 decimal places, I'll come up with positive 1.333. So next is to draw our sketch. So this is the negative value and this is the positive value. So the negative value will lie this side of 0 and the positive value will lie this side of 0. So we shall start with the negative value, which is that, and the positive value, which is that. Now shading means that they want values from negative 1.333 up to positive 1.33. So from here up to here, that is what we are going to shade. I have to remember that phi means from 0 to z value. So this is phi of negative 1.333 and this is phi of positive 1.333. So this probability is equal to the shaded part. So the shaded part will be got by adding this and this. So when I add these two, I'll be able to come up with this probability which they want. So I'll come here and say that this probability is equal to phi of negative 1.333 plus phi of positive 1.333. After that, I remember that by symmetry, this one is the same as this. Therefore, I'll go back in my mathematical table and look for 1.333. So 1.3 is here, then the second decimal point is 3, so it is here, drop it down to it will intersect at that point. Then the third one is also 3, so drop it down, it intersects at that point. After that, you remember that probability must be to 4 decimal places. So these are 4 digits, so to make it 4 decimal places, you just add 0 point here. But this is 1 digit, meaning that to make it 4 decimal places, you have to first add 3 zeros to make, and then after which you will add 0 points, so it becomes 0.0005. Then from there we shall use a calculator. So this plus this gives you 0.4087. So that is the probability. We shall come and write on both this and that. both this and that. So when we add, we shall come up with 0.8174. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, and this value has to be to 3 decimal places. Then M1 for this addition, B1 for this Z value, table value, and this one for this table value, and A1 for output after addition. So that brings us to another part called normal distribution in real situations. So here we don't add any other concept. What we do, we combine all the 3 concepts we have learned. We have learned how to sketch standard normal curves. We have learned how to standardize, to change from capital X to capital Z, and we have also learned how to use mathematical tables. So we shall use all that knowledge combined to come up with solutions to some of the questions. So now we shall go to question 4, which came from UNEB 2018, question 11 of subsidiary math. So it says, a factory sells animal food in bags. The weight of bags is normally distributed with mean, now this word mean, of 50 kilograms and standard deviation of 2 kilograms. Part A, find the probability that the weight of any bag selected at random, Roman 1, is more than 52 kilograms, Roman 2, lies between 46 and 55, and part B, determine the percentage of bags whose weights are less than 54. So in this part of real life situations, you must know what this one means in terms of inequality more than. What does it mean in terms of inequality between? What does it mean in terms of inequality less than? What does it mean in terms of inequality? So before anything, you must remember that the mean is 50 and standard deviation is 2. What does that mean? It means that mathematically we can write it as follows. So mathematically we shall write it in that form, meaning that x follows a normal distribution of mean 50 and variance 2 squared. Because standard deviation is square root of variance, it means that variance will be the square of standard deviation. So after that we shall go back to our Roman 1. Roman 1 said more than 52 kilograms. Now this word more than, in terms of inequality, it means greater than. So we are going to come here and write that the required probability is the probability of x greater than 52. After writing that, we shall now standardize. So this becomes z, the inequality sign is maintained. Now this value is changed to z value, so x is that, mean is that, and standard deviation is 2. Then when I use the calculator to simplify this to 3 decimal places, it will become 1.00. Then from there is to make our sketch. So this value is a positive value, means that it will lie on this side of 0. So let's put it there. And now that you shall remember, this inequality sign means of greater than means you shade going to the right. So we shall shade that part. Then from there, remember that phi means probability from 0 up to z value. So that is phi 1.000. And since the whole of this is 0.5, it implies that this remaining part is 0.5 minus phi of 1.000. Now this probability is equal to the shaded part, which is 0.5 minus phi of 1.000. Therefore, we shall go back to our mathematical table and look for 1.000, which will be 1.0 is there and 0 is there, which is 0.3413. So that is what we are going to write under phi of 1 to come up with that step, and when I use a calculator, I'll come up with that as the answer. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardizing, M1 for subtraction, B1 for subtraction and table value. So this B1 was for this table value and this one was for the output. So the question was had 4 marks. So now we shall go to Roman 2. Roman 2, they said, lies between 46 and 55. It means that x is greater than 46 but less than 55. So that's what we are going to write here and then standardize. So when I standardize, this one becomes that 46 minus 50 over 2, and this one becomes this 55 minus 50 over 2. When I use a calculator, this becomes that and this becomes this. Then after that I have to sketch the standard normal curve. So this negative value, the negative value lies on this side of 0 and this positive value lies on this side of 0. So let's put the negative somewhere there and the positive somewhere there. Now from this up to this, it means we're going to shade from here up to there. So let's do that. Then after that, I'll remember that phi means from 0 to a z value. So that is phi of negative 2.000 and this is phi of 2.500. Now the whole of this shaded part will be got by adding these two probabilities. Therefore this probability is equal to phi of negative 2.000 plus phi of 2.500. By symmetry, this one becomes that, and therefore I'll use a mathematical table now. So when I use a mathematical table, 2.00, it will be 0.4772, and 2.50, it will be 0.4938. So I'll come and substitute for phi of 2 and phi of 2.5 and use a calculator to come up with that as the required probability. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, and there should be 2 3 decimal places. M1 for this addition, B1 for the first table value, and another B1 for the second table value, A1 for the output after adding. So now we shall go to part B. Part B says, determine the percentage of bags whose weights are less than 54. So we shall first get the probability, after that we shall multiply by 100 to get the percentage. So we shall say that part B, first of all, the probability is x less than 54. So when I standardize, this x becomes z, inequality sign is maintained, and this one is standardized to become 54 minus 50 over 2 to come up with 2.000. So the good thing, so the first thing is to sketch. So when we sketch this, we shall come up with that. Then we shall remember that phi means from 0 to a z value, which is that, and the whole of this will be 0.5. Therefore this probability is equal to the probability of the shaded part, which will be this plus that. So we shall come and write that 0.5 plus phi of 2.000. Now the good thing we already saw in part Roman 2 above, that this value is that. Therefore when I add the 2, I come up with 0.9772. But the wanted percentage, so we shall come and say that the required percentage is equal to this probability multiplied by 100 to come up with 97.72%. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for standardizing, M1 for this addition, the B1 for the table value, A1 for the output, M1 for this multiplication, and A1 for the required percentage. So now we shall go to question 5, which came from UNEB 2013, question 13, and it says, a bakery produces loaves of bread whose weight is normally distributed. So this is the only way for you to know that that a given question is under normal distribution. So as long as it's under normal distribution, they'll always mention it somewhere that's normally distributed, with mean of 1000 grams and standard deviation of 40 grams. Part A, find the probability that a randomly selected loaf has a weight of at most 1020 grams. Then part B, assuming that the bakery makes 10,500 loaves, find the approximate number of loaves with a weight of greater than 950 grams. So here we have seen the same greater than. What does it mean? Equality sign, and also at most. So you have to know what these words mean in terms of mathematical inequalities. So we shall start with part A. So part A, we shall remember that when we read through the question, the mean is 1000 and the variance is 40 squared. Therefore, the required probability is x less than or equal to 1020, because they said the word at most. At most means that or less. Now here, remember this, from here now to this, you will write just less than, or you can also put less than or equal to. All is okay, but to maintain the inequality symbol after standardizing, you can just use the inequality of less than. Then here x becomes z. Then this is 1020. You have to standardize it by saying minus mean over standard deviation, which is square root of variance. Now when I simplify all this, I'll come up with 0.500 to 3 decimal places. Therefore, next is to make a sketch. When I make a sketch, I'll come up with that. And then I remember this is the positive value, so it lies somewhere this side. So let's put it there. And the inequality is less than means that I have to shade going to the left. Therefore, I'll come and shade that. Then I remember that phi means from 0 to z value. So this from here to here is phi 0.500, and the whole of this is shaded, meaning that this probability is 0.5. Therefore, this probability is equal to the area of the shaded part, which will be 0.5 plus phi of 0.500, which is that. Therefore, I'll go back to my mathematical table and look for that value. So 0.50 is 0.1915. So I'll come and write it there. That's 0.5 plus 0.1915. So when I add the two, I'll come up with 0.6915. So basically, that's what they wanted. Now let's see how much can be awarded. So the M1 is for identifying required probability and standardizing. So this one for identifying that this is the required probability using the correct symbol, and this one is for standardizing to 3 decimal places. B1 for standard value. So this one is for standardizing, so it will be given at this part, and this one is for the output, which is the standard value. So this is what we call a standard value. Then M1 for this addition, B1 for table value, and A1 for the output after addition. So now we shall go to part B, which says that assuming that the bakery makes 10,500 loaves, find the approximate number of loaves, note the word approximate number of loaves, with a weight greater than 950. So greater than means x is greater than 950. So we are going to first get the probability. After that we shall multiply by the total to get the approximate number of loaves. So this is the required probability, x greater than 950. We have to standardize, so this x becomes z, the inequality sign is there. Then this one has to be standardized to 950 minus 1000 over 40 to come up with negative 1.250 to 3 decimal places. The next is to draw a standard normal curve. After which, remember that this is the negative value, so to must lie somewhere this side, so let's put it there. After that, you look at this inequality greater than means that you shade to the right, therefore you shall shade all that part. Then remember that phi means from 0 to a z value, so from here to here is phi of negative 1.250, and the whole of this is shaded, meaning it will be 0.5. Therefore the total area shaded will be this plus this, which will be this probability, so we shall come and write that it's equal to 0.5 plus phi of negative 1.250. Then by symmetry this becomes that, after which we shall use our mathematical table. So mathematical table 1.25, like I said, you should look at this line. When you go look at this line, after this value it is empty, meaning that you have to drop down because these values are still under 1.2. So 5 so 5 is the second decimal point, so it lands on this. These are already 4 digits, meaning the probability will be 0.3944. So come on here and substitute, then add to come up with that answer. But remember, they wanted number of loaves, approximate number of loaves, so we have to multiply by the total number to come up with this value. Therefore the approximate number you round off to come up with that. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for identifying the required probability, another M1 for standardizing, and B1 for the standard value, B1 for symmetry, M1 for addition, B1 for the table value, A1 for the output, M1 for this multiplication, and A1 for this conclusion. Now before I conclude this video, permit me to pass on this information that as Roa Publications Limited, we have compiled a number of books for our viewers. So one of the books is Alevel Mastering Alevel Mathematics Paper 1. This book contains the entire syllabus of Uganda as per NCDC, so it contains clear notes, worked examples, and trial questions on algebra, geometry, calculus, trigonometry, and vectors. Then also another one is Mastering Alevel Mathematics Paper 2, which also contains clear notes, worked examples, and trial questions on mechanics, statistics, probability, and numerical methods. We have also compiled Mastering Alevel Physics Paper 1, and this one also contains clear notes, worked examples, and trial questions on mechanics, heat, and modern physics. We have also compiled Mastering Alevel Physics Paper 2, which contains also clear notes, worked examples, and trial questions on geometrical optics, that is light, physical optics, that is waves, electrostatics, electricity, magnetism, and alternating current. We have also compiled Mastering O-Level Physics Volume 1 of 2. This one contains notes of Senior 1 and Senior 2 with worked examples, trial questions, and their answers. We also have Mastering O-Level Physics Volume 2 of 2. It also contains clear notes, worked examples, trial questions, and their answers for Senior 3 and Senior 4 students. We have also compiled Mastering A-Level Subsidiary Mathematics Paper 1 for students offering subsidiary math. You It contains all the topics and there is statistics, probability, mechanics, and pure math for subsidiary mathematics. We have also compiled UNEB questions, but this time around they have been sorted topic by topic and from the years from 2020 up to 1987. Those are over 36 years. So I believe it will be a very good book for students, especially in Senior 3 and Senior 4 and also Senior 2. We have also compiled UNEB questions for A-level, and also we have compiled them topic by topic for the years from 2020 up to 1988, and I believe this will be suitable for students in Senior 5 and Senior 6. We have also compiled an O-level physics question bank. Also still it is topical questions, so the question banks we arrange, they are topical from 2020 up to 1987, and lastly also a physics question bank topical from 2020 up to 1988. So for orders, in order to get these copies, you can contact the managing director on +256 or 785 609713 or +256 or 704 989851, or email at roaelearning@gmail.com. So that brings us the end of this video. Thank you for watching, and be reminded that next video will be on motion in a straight line. So normal distribution is the last topic under probability. So now we are going to begin on mechanics. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on motion in a straight line has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.